Ever wonder how your email filters spam or how Netflix knows just what you want to watch next? It's not a mind-reading trick or a crystal ball. It's an intricate dance of algorithms and data, a technological marvel that's becoming an integral part of our daily lives. It's the reason your virtual assistant understands your voice, or how your car can parallel park itself. It's behind the targeted ads that seem to know you better than you know yourself. These aren't magic. They're examples of machine learning in action. So what is machine learning, really? Imagine you're teaching a toddler how to differentiate between a cat and a dog. You show them pictures of cats and dogs, pointing out the distinct features of each. After a while, the toddler starts to identify cats and dogs on their own. Now, replace the toddler with a computer, and you've got the basics of machine learning. It's about teaching computers to learn from data, just like how you taught the toddler to recognize cats and dogs. Machine learning is a type of artificial intelligence that enables computers to learn from and make decisions based on data. But how does this happen? Let's dive a bit deeper. The process starts with feeding the computer a lot of data. This data could be anything: pictures of cats and dogs, stock market trends, weather patterns, you name it. The computer then uses algorithms, which are essentially sets of rules or instructions, to sift through this data and identify patterns. Think of these algorithms as a recipe. Just like how a recipe tells you what ingredients to use and how to use them to make a dish, these algorithms tell the computer what data to use and how to use it to learn something. The more data the computer has, the better its dish will be. Once the computer has identified these patterns, it can use them to make predictions or decisions with minimal human intervention. For example, after being fed with a lot of weather data, a machine learning model could predict whether it's going to rain tomorrow. However, it's important to note that machine learning isn't about creating machines that think exactly like humans. Instead, it's about building machines that can learn from experience and improve their performance over time, much like how we humans learn from our experiences. In essence, machine learning gives computers the ability to learn and make decisions on their own. Now that we know what machine learning is, what are its key components? Machine learning is like a puzzle, and like any good puzzle, it consists of several key pieces that must fit together perfectly. These pieces are data, algorithms, and models. Imagine you're trying to make a delicious meal. The first thing you need is a recipe. In machine learning, your recipe is your data. It's the raw information that you'll use to make something amazing. This data can come from a variety of sources like social media posts, medical records, or even the weather. The more diverse and abundant your data, the better your results will be. But remember, quality matters more than quantity. It's better to have a small amount of good quality data than a large amount of poor quality data. Next, you need a chef to prepare the meal. In machine learning, the chef is the algorithm. An algorithm is a set of rules or instructions that the machine follows to learn from the data. There are many types of algorithms, each with its own strengths and weaknesses. Some algorithms are good at finding patterns in data, while others are good at making predictions. Selecting the right algorithm for your task is crucial. Finally, you need a kitchen where the chef can work. In machine learning, the kitchen is the model. A model is a mathematical representation of a real-world process. It's where the algorithm applies the data to make predictions or decisions. Once a model is trained on a set of data, it can be used to make predictions on new, unseen data. Just like in cooking, the recipe, the chef, and the kitchen must all work together to create a delicious meal. In machine learning, the data, the algorithm, and the model must all work together to solve complex problems. So there you have it. The key components of machine learning: data, algorithms, and models. They're the ingredients that make machine learning not just possible, but incredibly powerful. These components work together to make machine learning possible. Machine learning isn't a one-size-fits-all concept. It actually comes in different types. Let's dive into the three main categories: supervised learning, unsupervised learning, and reinforcement learning. Firstly, supervised learning. Think of it as a student-teacher scenario. The algorithm, like a student, learns from labeled data akin to a teacher's instruction. For instance, if we feed the algorithm images of cats and dogs, explicitly telling it which ones are cats and which ones are dogs, it will learn to classify unseen images into either category. This is supervised learning, where the algorithm learns from directly labeled examples. Next, we have unsupervised learning. This is a bit like learning to swim by being thrown into the deep end. The algorithm is given a data set without any labels or instructions. It's up to the algorithm to find patterns and structures within the data. A good example is a music streaming service that categorizes songs into different genres without being explicitly told the genre of each song. This is unsupervised learning, where the algorithm learns to find patterns and make sense of unlabeled data. Lastly, there's reinforcement learning. Picture it as training a dog. You don't explicitly tell the dog what to do. Instead, it learns through trial and error. When it does something right, it gets a treat. When it does something wrong, it gets no reward. Similarly, an algorithm learns by interacting with its environment and receiving feedback or rewards for its actions. A well-known example is the self-driving car, which learns to navigate roads and avoid obstacles by receiving positive feedback for safe driving and negative feedback for collisions. These three types of machine learning each have their strengths and are suited to different kinds of problems. Supervised learning is great for classification and regression tasks. Unsupervised learning excels at discovering hidden patterns, and reinforcement learning is perfect for tasks that involve decision-making and interaction with an environment. Different problems require different types of machine learning. So, where do we see machine learning in our daily lives? Machine learning is not just a buzzword. It's a reality that's shaping our daily experiences in ways we may not even realize. Let's dive into some of the real-world applications of machine learning. First up, recommendation systems. Have you ever wondered how Netflix knows what shows to suggest, or how Amazon decides which products to recommend? It's all thanks to machine learning algorithms. They analyze your past behavior, preferences, and interactions to predict what you might like in the future. So, next time you see a movie suggestion pop up, remember, there's a complex algorithm at work behind the scenes. Next, let's talk about voice recognition. It's a technology we often take for granted, but it's a key application of machine learning. Whether you're asking Siri for the weather update, or dictating a text message to Google Assistant, or even asking Alexa to play your favorite song, voice recognition software is hard at work. These systems use machine learning to understand, interpret, and respond to human speech, making our interactions with technology more natural and intuitive. And who can forget about self-driving cars? These marvels of technology wouldn't be possible without machine learning. From interpreting traffic signals to avoiding pedestrians and other vehicles, machine learning algorithms help self-driving cars navigate our roads safely. These vehicles are equipped with sensors and cameras that gather data about their surroundings, which is then processed by machine learning systems to make split-second decisions. But that's not all. Machine learning is also used in healthcare for early disease detection, in finance for fraud detection, and even in agriculture for predicting crop yields. The applications are as diverse as they are impactful. Machine learning is not just a futuristic concept. It's a part of our everyday lives, making tasks easier, experiences richer, and decisions smarter. Whether we realize it or not, machine learning is everywhere, shaping our daily experiences in ways we may not even realize. Now that we've unraveled the mystery of machine learning, let's summarize what we've learned. We started our journey by defining machine learning as a branch of artificial intelligence that enables computers to learn and make decisions without being explicitly programmed. It's a field that's been growing exponentially, becoming an integral part of our everyday lives. We then dove into the key components of machine learning: data, algorithms, and models. We explored how data is the lifeblood of machine learning, fueling the algorithms that in turn create models capable of making predictions or decisions. We discussed how these components work together, creating a cycle of learning and improving. Next, we examined the various types of machine learning: supervised, unsupervised, and reinforcement learning. Each type has its unique approach and use case, but all share the common goal of enabling computers to learn from experience and improve their performance over time. And finally, we looked at the real-world applications of machine learning. From personalized recommendations on shopping websites to voice command technologies in our smartphones and even self-driving cars, machine learning is revolutionizing industries and our daily lives. We've only scratched the surface of this fascinating field. There's so much more to explore, to learn, and to understand. So next time when you see a personalized recommendation or use voice command, remember, it's not magic, it's machine learning.